Hi, my name is Sepulveda. I'm in General Physics 1, Section 30668 with Professor Ansari, and today I'll be discussing inclined planes. I'll be discussing the principles of them, a little brief history, and the forces that act on objects on inclined planes. So inclined planes, in the simplest sense, are essentially just tilted surfaces. As long as they are at an angle to the horizontal, they can be used to maneuver heavy objects from one elevation to another elevation using less force. Inclined planes have been used for thousands of years. The first dates Inclined planes have been used for thousands of years. The first known usage was used by the Egyptians in the creation of the Great Pyramids. Ramps were used to transport the large limestone blocks from the ground up to the different steps of the pyramids during construction. Different examples of inclined planes include slides, sloping roads, windshields, ramps. Inclined planes are fairly easy to construct. Essentially, all you need is a surface that connects from the top of an elevated surface to the ground plane. So a surface such as this notebook easily spans the distance between the bottom of the plane and the top of the new surface. And here we have our inclined plane. So the green triangle represents the inclined plane with our angle theta and the right angle right here. The brown rectangle represents the change in elevation from point A to point B. And our blue square represents the mass that shall be sliding along our inclined plane. So at all times, an object resting on an inclined plane experiences a number of forces. So in total, it is 6 forces. We have the normal force, which is the force applied from the inclined plane onto the mass to keep the mass from sinking into this surface. The normal force is equal and opposite to the gravitational force of gravity, which is represented by the mass times gravity times the cosine of theta, because it goes to the opposite direction of the normal force. Then we have the force of the weight, which is the mass times gravity. That one goes straight down. And then we have an additional gravitational force, then we have our parallel gravitational force. It runs parallel to the inclined plane. That is represented by the mass times gravity times the sine of theta. The symbol right here represents mu, which also represents the frictional force. If the frictional force is less than the force of the mass will remain stationary. It won't go anywhere. But if the force of the friction is greater than the mass, then the mass will slowly begin to slide down the ramp. If an additional force is applied by F, this string, if it overcomes the both gravitational force and the force of friction, then the mass can slide up the incline. As far as physics principles go, inclined planes are a fairly straightforward concept. They're used in our everyday, today lives, and they've been used for thousands of years. So I hope this was informative.